Hello students. In this video we're going to continue on from our chapter 6 discussion. We're going to go into assignment problems. So assignments problem is a special type of linear programming model. It's very similar to transportation. It's going to be set up quite similar. The only difference is that supply and demand at each destination or source is limited to 1. So similar in terms of a balanced model, supply equals demand. There could be an unbalanced supply as well, and of course there could be situations where the cost of assigning a problem or assigning a solution is prohibited. So we would enter a very high cost for that. The example we're going to work with is where we are assigning officials to 4 games. We're trying to minimize the travel time. So perhaps this is, what does it say? Let's pick basketball. I think this is this. So there's 4 teams of officials to 4 games. We want to minimize the total distance traveled by the officials. So sending an official A to Atlanta is only 90 miles. Sending them to Durham, 180 miles. Sending official C to LA is 175 miles, and so forth. So basically we want to find the right combination that will minimize our total distance traveled, and hence that's going to reduce our total cost involved. So we're going to set up an Excel spreadsheet. It's going to look like this one here, where we have the 4 officials. We don't have any assignments made, but the teams that are available, there's basically here, we're only sending 1. So it's balanced because there's 4 officials and there's 4 places that need teams. The travel time is down here, and these are the same numbers we saw in the spreadsheet. So most likely we're not going to send official A to LA because that has the greatest distance, but depending on the combinations that the other combinations are involved, that very well could be one of the options here. So we in our Excel spreadsheet we're entering 1 as the teams of officials that are demanded, and then the teams of officials that are available, entering 1 as well. We need to have this sum product function in here. It's basically going to take these cells, multiply each individual cell by the corresponding cell in that table. So once again, if we entered 100 here, there it is. Oh no, we're going to enter 1 there. We can't enter 1 here because now we're assigning 2 officials to that place. So that's why the assignment also needs to be 1. So we can work out various possibilities ourselves, but we're not going to do that. Just showing you that that sum function, or that sum product function, basically takes the corresponding location in one table, matches it with the corresponding cell in the other location, and multiplies them together. So let's work this out. Make sure everything is set up. The teams assigned for officials is basically the sum of those numbers. We can see that there. That's 2, so it is working. Well, let's go into Solver. We're going to set this up. It's a minimization problem. Trying to minimize the total mileage by changing variables in this cell location. We're going to add 2 constraints, the supply and demand constraint. We're going to basically go C10 to F10 is going to equal C9 to F9. And then we're going to do the same thing here. We're going to go H5 to H8 is going to equal the number of officials that are available. We're going to click OK to that. And that is all set up. So we're looking at 2 different arrays. We have the mileage array down here, plus we have the array of the actual assignments. So we're going to solve this. And look at that. The total mileage is 450. That's the lowest combination. Our demand constraints are met and our supply constraints are met as well. This is a balanced situation. So we know that we're going to assign official team official B to Raleigh, official team A, the officials in team A to Atlanta, and so forth. Now, if one of those assignments is now prohibited, say for whatever reason we can't assign official team B, the officials in team B, to Raleigh because of perhaps they are from that area, and you want officials perhaps outside of that home area. So basically we go down here and we make this cost really prohibited. So let's just enter a big number. A big number, it doesn't have to be that large, basically just big enough to convince the solver in Excel not to make that assignment. So we can go and solve this, and there it is. Our cost now has gone up. It's 450. And there we go. So let's change this back. Solve it again to work on another scenario. Ooh, our cost didn't go up. Found another alternative. So let's work on a situation where perhaps there is no game played in Atlanta. So they don't demand a situation, a group of officials. So we're going to assign that to be 0. It's now an imbalanced model. So we're going to get an error message here, but we can still find that, well, basically we're not assigning to Atlanta. Atlanta seems to have some of the cheaper costs, cheaper travel times, but we're not making that assignment. We have prohibited it. So let's go back, enter 1 there, go back to original. There it is. We can do the same thing here. We can, for perhaps official team C is no longer available. They can't officiate this coming up weekend, so one of these places is going to be without an official. Go back here, solve it. We're going to get that error message, but we can still work through this. So because we're only traveling to 3 cities, our total mileage is down, but Durham is not getting any officials. There we go. Team C can't be available. That means that Durham is out of luck. So that's the one city that's not going to get officials for their basketball game. Oops, let's make this back to original. Solve it again. And that is our assignment problem.